Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Demystifying REST Architecture and Design in SOA Context, and this is the 12th session in the Cloud Computing series. Our guest speaker today is Mr. Mallari Kulkarni, a consultant at EMC. Mr. Mallari works as a consultant software engineer with EMC, focusing on applying service orientation and REST to product architecture and providing technical direction to 100+ engineers. He has been in the industry from 1995 and has worked as architect in Fidelity Investments, Symphony Services, Blue Star Infotech Limited. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Mallari.
Yeah. Hey, good afternoon and good morning and good evening, because some of my colleagues from US and other countries are also joining. So that's the reason I said good afternoon, good morning and good evening everyone. First of all, thanks for attending this session. So the focus of today's session is intentionally, basically there are two things. In the industry, that people do talk about service-oriented architecture and also about the REST architecture. So I wanted to basically give a perspective of what is REST architecture, what is SOA architecture, and how REST is still relevant in terms of service-oriented architecture. Okay. So as she talked about regarding the speaker profile, so just I wanted to give a quick introduction. So basically, I'm working at EMC from last 1 year as a software architect. I do have around 16 years of application and enterprise architecture experience. Currently, I'm working as one of the core product called as Storage Resource Management Suite product. It is one of the leading industry software, and I've been providing a technical direction to across 2 geographies, US and India, around 150+ engineers. Coming back to the product which I'm working on, basically it's a product which enables IT professionals, basically data center administrators, to manage the storage resources effectively. If you look at it in today's world, because of social mobility, so much data is being generated. When so much data is being generated, you need to manage the storage resources efficiently. It could be performance, it could be availability. So the product which I've been working on, that's a storage resource management product, addresses that challenges and solutions. If you would like to understand more, I've given you a link in the below, so you could go and look at it. I'm also a certified service-oriented architect and a trainer. It's basically there's something called SOAschool.com. It's a vendor neutral and technology neutral. So that is one thing I liked about this the courses and the school philosophy. So it always, as an architect, what always I look across is how best I can design a solution and most of a technology and vendor neutral. So that's it about me, and what I plan to cover today is, in the agenda is basically, there are 4 things I want to cover is introduction to SOA, service-oriented architecture, introduction to REST, and REST design patterns, and also talk about the EMC data access API. So just to cover it up, I'll try to cover it up, what is SOA and what is REST, and then I'll talk about something on REST design patterns, and also talk about what are the best practices the EMC is adopting it. Those best practices I will try to share it, and which are being leveraged within our products. So moving on to SOA, and first of all, if you are very new to the service-oriented architecture, I would recommend you to go just definitely read one of the great authors called Thomas Earl. There are 2 books are there. One is called service-oriented architecture concepts, technology and design. The other one is SOA, principles of service design. I just now showed you both these two books. So if you are a novice to service-oriented architecture, I would highly recommend you to read these two books. They have explained the concept pretty well. Again, when the concept has been explained, they explained it pretty well in terms of vendor neutral and technology neutral, keeping in the focus. It's a concept that can be applied to any technology. It can be Java, it can be C++, it can be .NET, so any technology. Moving on, in SOA, there are two, just I wanted to quickly touch base. In case of service-oriented architecture, the first thing comes called a service. What is service? Service is nothing but a collection of capabilities. Whenever any service it has two parts. One is a contract, other one is a logic. The contract is nothing but the interface what you expose to the outside world. This is very interesting. I wanted to just say the service is called a service-oriented if service-oriented architecture design principles are applied to a meaningful extent. The reason I'm trying to say the meaningful extent is because whenever you have any architecture design principles, you will always have a conflicting always priorities. Which one should be applied what? So that is an architect responsibility that it should be applied to the meaningful extent as per the business needs, because always a trade-off is required whenever you are trying to apply any principle. You can be always apply 100% purity, but if you do not meet the business needs, so then the architecture is no use. So what I'm trying to say is that apply the principle to a meaningful extent, which will give you both the business benefit and also the architecture benefit. So moving on, what are those design principles? The service-oriented architecture has 7 design principles. Again, there are too many authors have written too many about many things. What the Thomas Sowell has done is basically he's tried to focus on the vendor neutral and the technology neutral, and he's came up with these 7 principles. The 7 principles basically are, I have listed down, basically a standardized service contract. This principle is one of the fundamental principles of service orientation. Just look at it. If you are developing a product, you expose multiple services to provide relevant information. Taking an example of employee services. Now when you expose employee services, you do have an employee ID. Now if you have an employee ID, the same data type and the structure across various services, because this employee ID may be referred in multiple services when you are in your system. So when you have it in multiple services, what it's trying to say is that standardize the contract. Wherever you use the employee ID, use the same data type, same data structure, same data validation. That's what it's trying to say. So what is the advantage of having this one? This reduces the need of data transformation. Let's say in some places if you expose the contract as string, and in some places you expose the data as numeric, then what you will end up in doing is you need to do a transformation of the data. So what the principle is trying to say is that by applying a standardized service contract, you reduce the data transformation. Moving on to the loop coupling. So again, this is a pretty industry well known. Like even when you come across from the object-oriented principles, you do know that all the classes, whenever that one class needs to interact with another class, they should be loosely coupled. So just to again highlight one thing is the service-oriented architecture is nothing new. It is made up of the best practices of procedural-oriented languages and the object-oriented design languages, object-oriented analysis and design. So it's a combination of the best of breed across whatever we follow the traditional, and those best of breed has been basically classified into 7 design principles, 8 design principles which have been listed here. When you look at coupling, there are various types of coupling. Basically, when you look from the service-oriented architecture perspective, there are 2 things are there. One is a service consumer, service provider, and the service which basically what it's exposing through a contract, and the other one is a logic. So at any point of in time, contract should not be dependent on logic. Logic can be dependent on the contract. So there are various types of couplings exist, and always you should have always a negative. You should not have a negative coupling. You should always have a positive coupling. It means loosely coupled. Moving across quickly to abstraction, the main goal of this principle is to keep the details of the quantity and the detail of contract pretty concise and balanced and prevent unnecessary access to additional service details. So that will ensure a good level of abstraction. Moving on to reusability, any service which is highly agnostic or basically reusable is called service reusability. So when I say agnostic means basically it does not depend on too many parameters. It's completely the context agnostic. So that's what is called as service reusability. So coming back to the service autonomy, it is any service which has a high level of control over its resource. That's called as that is called as service. The service is autonomous. When I'm trying to say it has a high level of control, let's say if there are incoming number of requests is more than 10 or 100 or 500. So automatically the service should be able to handle all the incoming number of requests. Even though there's an increase in the load, it should be able to increase the resource capacity automatically. So that's called as service autonomy. Statelessness means just basically a service should be stateless, so that make the service as much as stateless, so that it is basically it does not occupy too many memory resources. Composability means the one service should be able to call another service, and the discoverability is pretty much what I'm trying to say is that you should expose the metadata information which will help the service can be quickly identified for which business purpose. So these are the key 7 fundamental principles of service orientation. If you want, again, there's an exclusive 1 hour session can be conducted exclusively to talk about these service oriented design principles. As I wanted to give you both glimpse of SOA and REST, I'll try to provide those are the design principles. Just to cover up, a service is called service oriented if these 8 design principles are applied to a meaningful extent. Okay. Now coming back to the REST, again, if you are novice to the REST, if you are never worked on the REST, I would recommend again reading 2 books called REST API. One is published by Orally, and the other one is called RESTful Web Services. So these 2 are the books basically which will provide you a good kickstart on the web. Okay. So what is REST? Basically REST stands for representational state transfer. Okay. The other thing also I want to talk about was how does this REST originated, the word. Just give me a second, I think. Yeah, the REST originated basically. There was a professor called Roy Fielding. In his doctoral research, basically in his research during his doctorate program during 2000, basically he invented this word called as representational state transfer, or basically REST services. He was the principal author of HTTP specification 1.0 and 1.1, and later it was developed by W3C Technology Architecture Group in parallel with HTTP 1.1. So just to summarize, it's all started during 2000, and then later W3C picked up as part of Technology Architecture Group, and then they worked on this REST. Okay. Now moving back ahead, so basically I wanted to talk about something on REST service design constraints. See, again, if you look at anything, there's always a specification, there's always something called implementation. The implementation is more specific to a technology, and always whenever I try to give any information, I always talk about more on the specification. So it can be any service as long as they follow these design constraints, it's still called as a RESTful service. So if let's say if the technology is written in C++, okay, what I'm trying to point out is that if any service which follows these 5 characteristics, design characteristics, the first characteristic is basically a client server. So what do you mean by client server? Basically client should be independent, the server should be independent. So basically everyone is aware of it. Then the second principle, what I'm trying to say is that it should be stateless. Any resource what you are trying to expose should be stateless. Third thing is, when a server sends a data to client, there should be a mechanism where the server can say that use a cache data from your client. Okay. Third, it should be layered system. Client should not be aware of that it is communicating to which server. in between there can be multiple, again, services could be introduced. That's called a layered system. The fourth, basically, which talks about uniform contract or uniform interface. So the uniform interface, basically there are 4 guiding principles of uniform interfaces. You should be able to identify a resource by something unique ID. Okay, that's one principle. The second thing is basically the message should be self-descriptive. The third principle is it's called HETIOS, hypermedia as an engine of application state. What is trying to say is basically clients make state transitions only through actions, okay, that are dynamically identified within hypermedia by the server. So what he's trying to say is that whenever you make a request for the server will give you, in case we need more information, the server provides those links, what are those, how you can get those information. And the last part is basically the code on demand. So what this is trying to say is servers can temporarily extend or customize the functionality of a client by transfer of executable code. What he's trying to say is that if server wants to execute extra code, it should be able to send that extra code to the client, and the client should be able to execute it. As long as these 5 characters can be implemented by any technology, it can be C++, anything. As long as these can be implemented, okay, then it's called RESTful service. However, what is happening is in the industry, the communication of World Wide Web, like HTTP, using HTTP, exhibit most of these design principles. Because of that, we use HTTP as a mechanism for RESTful services. Remember that HTTP is not the only way. You can build your own algorithms to implement these design characteristics. Still, it can be called as a RESTful services. So that's about the REST design principles, and basically those are the 5 guiding principles for any RESTful service architecture. So just to again, I want to emphasize here is that technology is not the which will decide what is RESTful service. Okay, technology can be anything as long as it adheres to those 5 fundamental principles. Okay, client server, stateless, cacheable, layered system, and uniform interface. That will make any service called a RESTful service. Moving on to the REST URI. REST basically, when you talk about it, one of the fundamental principles was saying that uniform interface. When I say uniform interface, each resource should be identified by unique URI, any ID. So that ID is nothing but called as URI. Okay, basically uniform resource identifier. So if you look at it, there are multiple things are there. If you look at, there is scheme, there's the authority, there's a path, there's a query, there's a fragment. So if the first part, basically the HTTP is a URI scheme, and the abc.com is an authority. So basically the employees is a path. So what this URI is trying to do is trying to get the list of employees, okay, and where the employee belongs to something department ID as 1, and also it is looking for a second page. It is requesting for a second page. So if you look at it, if you are looking anything, whatever you request after the query parameter is called as fragment. Anything after the question mark is called as query. The path is nothing but in a way the service name. The authority is abc.com, and the scheme name is HTTP. So this is about the URI. So moving on, when you are designing a URI, there are multiple guidelines exist. Like a few of the guidelines are basically URIs prefer nouns to verb, and keep the URI as much as short, because I mean most of the browsers, some of the browsers at least have a 4 kilobytes as the limit, and REST URI should not be constructed by client. Again, this is one of the HETIOS principle. So what we are trying to say is that, let's say if you get the list of employees, in that result, pretty much you should get, if you want to get the individual employee detail, you will get the hyperlink in that result only. I'll try to demonstrate these through some of the EMC best practices in my further slides. Okay, and then use redirection when you really need to change it. Again, I do have some kind of a pattern which talks about this, when the redirection should be used across within the REST services, which will be covered in further few slides. Okay, so I talked about REST design principles. I also talked about REST URI. Now, when you are communicating the REST services, there is always something called media types. So when you are communicating with any service, the service may send the various types of data. So some of the data which I have tried to list here was one of the, we use a lot of atom feeds. There's another pretty much which is standard is basically JSON. Another standard one is the XML. So the REST supports various media types. Some few of them only I have listed here. That's what it is. Now the question arises, yes, the SOA has 7, there are those 8 design principles are there. REST has its own design principles, those 5 characters like client server, stateless, cacheable, uniform interface, code on demand, layered system. So what is REST and what is SOA, and should we use any one? The question arises in most of the developers and architect mind saying that is SOA is better, is REST is better, or should I use both? So though it looks like both the service-oriented architecture and the REST appears as 2 distinct architecture styles, but we do not have to select any one. Okay, basically, if you look at SOA, SOA has a lot of business goals like increase return ROI, business and technology alignment, reduce IT burden, increase federation. But REST goals are more of technology-centric and can help to solve strategic or tactical business goals. Remember that again, REST is one kind of a technology or a media to implement SOA. Okay, so SOA can be implemented using web services. SOA can be implemented using C++. SOA can be implemented in using Visual Basic. Any technology is immaterial. So REST acts like one of the technology media to implement SOA principles. So bottom line, there are no conflicts between REST and SOA. They complement each other. In fact, in our product, which I'm working on, the storage resource management product, it is built on service-oriented architecture principles, okay, but we expose all our services using REST technology. So they complement each other. They are not competing each other. They are complementing each other, and that's the message I wanted to communicate it. Okay. Let me see any questions are there. No, I don't see any questions right now. Okay, so just to touch across, there are some common goals between SOA and REST. Basically, what ultimately both will try to, the design goals are, it increases the standardization, it increases the scalability, it increases the reusability, interoperability, vendor neutrality, and responsiveness to change. So when you combine, basically, if you implement SOA with REST, so these are the design goals which can be achieved by adopting SOA and REST. That's what I want to say. So moving on to the next slide is basically the REST design patterns. If you look at again, though I called it a REST as one of the technology way to implement SOA service-oriented architecture design principles, what I also want to touch across was basically some of the patterns which are available in the REST. There are various patterns are there like content negotiation, endpoint redirection, uniform contract, entity endpoint. I'll try to touch across 1 or 2 in this presentation. You could also, if you need more, again there is one more book called as SOA with REST. You could look at that and then try to get to more details. If you look at content negotiation, what happens is, let's say you develop a service, okay, and there is a web browser. You develop a first of all client is web browser, and when the service wants to interact with the web browser, typically they may send the data using XML. Tomorrow you may have a new device which may want to interact using JSON. So what we are trying to say is that the REST task, it supports various media types. Okay, the client can negotiate with the service what kind of basically the data it wants it. It may require for a JSON, it may request for a XML. So if you look at here, when the client makes a request, get employee, it's giving it 3 options. It's requesting for HTML, XML, or JSON. And when the server responds it says, okay, I'm sending you the data back by JSON. So during the GET request, what it has requested is basically trying to say that I can accept the data in 3 formats, whichever you wanted you could send across. If the server is unable to send any one of those 3 formats, server typically replies with 406. That is the response code as per the HTTP specification. The first example talks about what are the possible things. The second example tells you about the priority what the client wants it. The client is trying to say that if you give me the response in XHTML plus XML, that is the highest priority I'm going to take it. If you give the text HTML is the lowest priority, and the plain is the third most priority. So that is basically the priority how the client is requesting the type of data in what order it wants it. Basically that is the preference it is going to process it. Okay. So there is something other concept called multi-dimensional negotiation. If you look at REST, if you look at HTTP request, there are various, in the header there are various parameters can be sent across. One is the language, other one is the character set, the third one is the encoding. So I'll try to list down few examples here. So again, the content type JSON, atom XML. So how is the request header? It looks like how is the response? Just a sample example I'm trying to provide here. So gzip, language, content type, all these are the few examples which I wanted to show. So then moving on to the next pattern called an endpoint redirection. Let's assume that a service consumer is interacting with a service, okay, and let's say the service consumer is talking to a service for a while, maybe 6 months or 9 months. After some time, what happens? The service is duplicated. So basically it's the older version. So, but the consumer is not aware of it. How to handle this scenario? So what will happen is that in that scenario, what this design pattern is intended to saying here is the service should send a response code as 301, and should, along with the response code 301, it should send the new URI. Okay, then the consumer will use a new, if the response code is 301, what the consumer will do is it will automatically make a request to the new version. So this is called as an endpoint redirection. So basically one of the principles what we are trying to say is that the consumer should always look for the response codes, and based on the response code it should react to appropriately. If it is 200, it got the valid response. If it's 406, it did not get the right response. If it is 301, basically it needs to be redirected. So there are a few anti-patterns also which I wanted to touch across. If you are trying to make all the requests through one HTTP GET method, this is totally unacceptable. This is completely an anti-pattern because it increases too much complexity on the maintenance. Again, tunneling through one HTTP post method is again one more thing. Ignoring a caching, because one of the REST fundamental principle what it says is client should be able to cache it. Okay, and when the server use a cache data, it should use a cache data. So if you are writing a consumer for a RESTful service and if you are not analyzing the response code, then again you are not following the REST principles, and which will lead to an anti-pattern. Ignoring MIME type means content type. So those are the few examples of REST anti-patterns. Just to give a one clear-cut example of REST anti-pattern, I'll try to show you in the next slide, is that how typically the code looks like for a GET method. If you look at it, what is happening is there is a service called a customer, and what they are trying to do is that they are writing a method equal to add customer and name equal to ABC, whatever it is, and ID equal to 42. So this is basically a one service where you are trying to send different methods. This is purely an anti-pattern. Instead of that, you should expose a different URIs for each of them so that appropriate message can be provided. So when you through GET, it should be idempotent, means if the consumer makes multiple calls also, there should not be any impact. That's one of the things which I wanted to highlight here. So that's about okay, time check. I do have 15 minutes left. Okay, So moving on to the next slide, basically, which we'll talk about. I'll talk about more on the EMC data access API, which is built on REST data best practices. Okay, so we call it as internally called EDAA. That we are using that acronym within our organizations very effectively, and most of our products are exposed in the services through these principles, basically EDAA principles. And these are pretty good best practices, which typically most of them are followed, and we also follow it. If you look at it, APIs are tricky, and if you leave to the developers, basically, hey, you go and develop REST services what you wanted, and what will happen is that they may make their own URI names, which may not be right, may not provide the right meaning or right information, and ultimately what will happen is that it will lead to more maintenance, and it becomes complexity in the maintenance. And there has to be a consistency way of how do you handle the transactions in REST, how do you handle, basically how do you handle the security, basically how to advertise the documents. Basically, if you have a REST, you need to expose certain information. How you are going to do that? So bottom line, what I'm trying to say is that there has to be some consistent way of doing it. If you do not have the rules and regulations, the principles, it can lead to a disaster. So then what are the problems we are trying to address here? The problem what we are trying to address is basically how best I can provide a consistent information across products. Okay, because internally we have multiple products and we expose services for various products. It can be, leave the EMC. Any complex enterprise basically will have a lot of products, and to gain the maximum benefit or reuse, each product will expose as a service, and other products services will definitely try to reuse it. That's the way the returns of 1 plus 1. That's all I call it as 1 plus 1 greater than 2, where one service from one business or one product line can be reused across different business or different product lines. So to ensure interoperability across different products and better customization of what also it helps is basically it provides a consistent APIs, which will allow a easier integration instrument, and also it will provide a better customization. Okay, so moving on, if you look at it, I showed an anti-pattern in the previous slide where I talked about where a customer service was basically being called with various different methods called add customer, delete customer, basically update customer. So that is a purely an anti-pattern. The reason I called it an anti-pattern because they have their own custom method, and what is the REST recommends it? REST recommends simple, use post if you are creating a new customer. So what REST is trying to say is that everything is a URI. So okay, so use post, the standard HTTP methods, use post for creating a resource. If you are trying to read a resource, use get. If you are trying to update a resource, use put or patch. And if you are trying to delete a resource, use basically HTTP delete method. So if you look at the whole CRUD operations is directly modeled to the HTTP methods, and that's what is recommended of REST best practices, REST data access best practices. So now you should be able to compare why I was calling that as a more of a anti-pattern, because there it was following its own custom methods which were not a recommended industry way of doing it. These are, I call it as a EDA URI patterns. The reason I call it as EDA URI patterns because these are the EMC best practices, data access patterns, API patterns. If you look at it, I will try to showcase at least a few examples here. What the slash types will try to provide you is slash types will expose the metadata of the service. So if you look at web services, how do you understand the metadata? If any web service which is exposing it always gives you a WSDL. Okay, the WSDL gives you the signature of the contract, what is the input and output it is expecting it. So similarly, if you want to understand what the REST service is capable of and what are the data it is going to give us, so the way in which we have exposed the metadata of a service is basically through slash types. Okay, so I'll try to go through a few examples, and then probably you'll be able to understand these different types of what I've listed here. So what are the features of EDA? So it basically some of the features of EDA are, give me a second, I think the slide is taking a while. Okay, it enforces the URI patterns, and it's independent of resource model. It provides a read access to metadata, which I talked about, basically slash types. When as I compared with the web services, it exposes the metadata through the WSDL or some discovery repository. Here we expose the metadata through slash type services, and data can be available as through various media types, like whichever you wanted, JSON. And we have used extensively the atom links and HTTPS principles, and it allows a pagination, which is a standard of RFC 5005. So on top of that, it also allows sorting, filtering, a lot of other benefits. I want to go to the examples, a few examples, time check. I do have last 10 minutes because I want to keep last 10 minutes for questions. So I want to quickly move on to the few examples. Before moving on to the few examples, I would like to present the context of the problem statement. If you look at it in this picture, there is basically an entity called application. Okay, there are various applications are there. These applications belong to various lines of business. Some applications may be critical applications, and these applications are hosted in servers. Okay, and based on each application is its own SLA. Basically, if it's a business critical application, it may have a better SLA. If it's a non-business critical application, it may have a different SLA. So I wanted to, next step is basically keeping this model as a reference. I wanted to talk about the various use cases, how we are going to, how we are exposing the information for this kind of example. So a few of the use cases which I wanted to talk about was listing all applications, and then listing critical applications, how the filtering is done, how the sorting is done. So moving on to the first use case, if you look at it, the first use case, what is the pattern? What it says is list all the applications. Okay, as I talked about listing all the applications. Yeah, so the first type is basically the URI will look like get slash types slash application slash instances. Give us a second, I think there's a latency delay in the, yeah. So when the slash type slash application slash instance, the pattern, look at the pattern here. The pattern is basically slash types is basically a type, and the type name is, what is the type? Basically here we are trying to get the more data about the application. If you look at the application data, there are two things you can see here. There are two entry here. You can see there are two types of applications exist. Those applications, one is a BMC remedy, that's one kind of application, and its name, its version author, everything is there. Since we have requested for instances, what it's trying to do is it's going to get all the applications. Okay, so if let's say if there are 10 applications in the system, you will see 10 instances, about 10 basically application line items entry within the response. Okay, so if you want a particular one instance, basically, then what you need to do is that you need to give an ID for that, and then you will get appropriately for that. Okay, so the next example I want to talk about is the list all lines of business using remedy. So basically I want to list the applications, okay, list all lines of business which are using remedy as an application. Okay, so now if you look at the pattern again slash instance slash ID, because the ID is what here, remedy is the application, so that is an ID. Okay, so that is, then what is the relationship? The relationship is basically used by lines of business. See, look at it, the way in which we are exposing the information is, one way is in the traditional way you typically expose you write a one service saying that get application by remedy, so something like that, you expose a method like that. Here we have tried to standardize that as one of the relationship, because application has a relationship to a business. Okay, business can use multiple applications. So what we are trying to say is that any application, the application name is remedy, okay, and the relationship is basically used by lines of business, okay. So that is, so used by LOB is the relationship. So when you request like that, then automatically what will happen is that you will get only the data which is used by appropriate lines of business. So that's what is the, so the point I'm trying to highlight here is that this will ensure a consistent way of representing the data, exposing the data. So whenever the relationship exists, I give that relationship a name, and then when you give that, then you can retrieve a data for a particular resource with that relationship. So that is the beauty of the way in which this is being exposed. Okay. So moving on to the next use case, list all critical applications. If you look at it, critical application is basically a business critical application. So the type name is given as a business critical application. What this will do is it will list down all the list of whichever the application has been marked as a business critical, which requires a different SLA. It will get you the data. And yeah, if you look at in the here, what you can see is that you can see also page numbers, page 2 and page 20. Okay, so that is the beauty of any RESTful services. You do not have to construct the URI. The URIs are in the responses. If you need further the information, whatever is required is automatically provided as a link. Okay, and that link can be used to retrieve further more information. That is one of the reasons. One of the rest, the URI principle is you should not construct the URIs. Okay, you make a request at the top level. The further URIs are given as in the responses and use them as a links to get the additional data. Let's say if you want to get, I have 3 more minutes. Let's say if you want to get only the certain number of fields. Okay, the way in which it is the best way to expose is, okay, type name / instances. Okay, you have the instances, and then give them the OS name and the version number. So you'll see there, if you see in the responses, only those 2 attributes have been given in the responses. So this is the way typically if you want to restrict what output you want to do it. So this is one of the way to do it. This is one of the best practices we are following it up. Okay. Moving on to the 5th use case. The 5th use case is basically list all the servers sorted by some OEM. So basically what this is trying to emphasize is basically it's trying to talk about the order by clause. How do you request in a REST data access API that how do you make a request to get a data in a specific order? Okay, so in that scenario what we have to do is basically again use the same pattern, /types, type name, /instances, and then you write your order by. That is the query parameter, and write order by what is the specifier. Just write the specifier, it will automatically sort the data and it will get you the data. And the last one, basically if you want to apply the filters, because I showed you the sort, I also showed you basically the pagination, how the data is given there. So the last one now basically I want to talk about what basically the example is how if I want, because whenever I request for data I don't want all the data. Let's say if I want all the employees, if it's 1,000 employees are there, I don't want it. I want it filtered by certain thing. So what needs to be done basically in that scenario? Pretty simple. Again, use a pattern. After the question mark, what we are recommending is basically use filter equals and the parameters. So if you use apply, what will happen is that the URI, the resource, the service will apply this filter and will get you the data. That's it I had. These are the references. The references even I showed you initially in the books. Those are the books. Now I can open for questions if you have any questions. Mohini? Any questions? Mohini, are you there? I'm done with the presentation. If anyone has questions, please ask the questions in the questions window. I'll try to answer it. So okay, let me see the first question here. Let me expand the window and yeah. So okay, one of the question I got is, can we do parallel process? Okay, the question came from the Prasad. The question is, can we do parallel process for get, put, delete? Okay. So as I pointed out, for get and put as per the REST design principle is idempotent. Okay, when I say idempotent means you can request multiple times. Okay, even if you request multiple times, get does not have any impact. In case of put, what will happen is that if the resource is already there, then only if the resource does not exist, then it should be created. If the resource exists, it will not create. So that's the way it is being handled. And coming back to the parallel processing, yes, why not? I mean, it can do parallel processing also. Okay. Moving on to the next question from Hiten. To filter specific data within a field, how to construct a URI? Within a field, I mean, if you can use any wildcard character. I mean, if you want to construct, probably I'm not getting your question, but based on my understanding of your question, I'll try to explain the answer to the question. If you want to filter a data with a specific pattern, you could use always certain character like wild characters like star, asterisk, or a question mark, or if you have or you could use equal sign or greater than sign. So it's up to you. Basically, the query parameters can be passed whatever is required, and it can be used that way. Okay. The next question from D. Shankar. How is SOA related to REST? Again, I talked about it in the initial my slides only. SOA service-oriented architecture has certain design principles. It can be implemented in any technology. Okay, REST is one of the way. It is again a technology media where the SOA principles are implemented. So how SOA is related to REST is basically REST, as the nature of its design principles, it's evolved more over World Wide Web and over HTTP, and the goals of REST and SOA are complementing each other. And what I try to say is that in any true enterprise application, you apply SOA principles and you use REST as a technology media to implement it. Okay, that's the question. One of the question is, can we have an elaborated session on REST from Sushil Agrawal? Yeah, I mean, definitely. I don't know, is there a way, mechanism you could guys send a request to TechGig, and probably I'll be happy to take one more quiz, much more deeper session for that also. There's one more question from Himin Gohil. REST permits many different data formats, whereas SOAP only permits XML. While this may seem like it adds complexity to REST because you need to handle multiple formats, right? JSON usually is a better fit for data and passes much faster. REST allows better support for browser clients due to its support for JSON. Is it better to use REST rather than SOA? It depends on your requirement. Again, so it is unfair to say that SOA supports only one data format. Within the SOAP, you could again put, let's say if you want a different data to be sent across, you could send across a very different data, like even the bytes or something, you could send across. But as a REST, definitely, since it's directly relying on HTTP media types, it definitely supports more different data types. So again, to answer whether you want to purely go for, again, it all depends on your context. REST is one way of you implementing SOA. And if your requirements are more complex and it requires different technology, you could use web services also. It all depends on what kind of your enterprise integration requirements do exist. Okay, let me go to the next question. Okay, this question is from Hitain. How to handle a request that is long-running request? Okay, yeah, this can, again, what in our EDA specification, at least in the EMC data access, what we have done is we are calling it a task resource. That's the way it has been handled. Okay, let me look at another question. How RESTful web, this question is from Naveen Kumar. How RESTful web service is better than SOAP-based web services? Again, I believe I just now answered this. But RESTful web services, again, as I said, is RESTful support, any service which follows those 5 fundamental principles are RESTful web services. The RESTful web services, when you are comparing, I think when you are trying to say, I believe in your mind what you do is thinking that web services. When you compare REST services to web services is much more complex. It requires a lot of better infrastructure, and whereas REST follows pretty much the HTTP standards. Since REST is built on HTTP 1.1 specification, what is happening is that, and most of our clients are typically a browser-based clients. In that scenario, RESTful web service is much better than compared to SOAP. Because if you have SOAP web services, your client cannot directly analyze the data, because SOAP has its own structure called header and body. And again, so since it follows a different naming standards like the SOAP specification, so SOAP basically the web services built on anything on SOAP web services will not be directly consumed by the, cannot be consumed by the web client or a browser, like a browser. Hence, RESTful web service is recommended for client which are using web browsers. Okay, the next question is how easy is conversion from a web service to a REST service? Conversion from a web service to a REST service. It depends on, again, how it has been internally designed. If when you are designing a web services, if your business logic is completely abstracted from your external interfaces and which is really reusable, then what you need to change is only the external interface part. Because in case of web services, you are exposing your interface through SOAP. Probably here, if you want to go for REST, the way in which you expose information differs. So it all depends on the internal design, how granular you have gone in designing the classes and the hierarchy, the relationship. Okay, I'll take the last question because it's 3:59. How do I pull the REST service with different method? For this question is from Naveen Kumar. The question is, how do I pull the REST services with different methods? The different methods is basically what REST recommends is use a standard HTTP methods. Put, okay, get, delete, post or patch. So these are the way it is being exposed. So basically the CRUD operations is being mapped to that, and you should always use it. If you want to get additional data, like one of the example which I shown, where application is being used by multiple lines of business, then you define a relationship and then expose that data through that relationship. Okay. If you do have a questions, please do send across. I can reply back to you offline. My email ID is mallari.kulkarni@emc.com. I'll be happy to reply back to you. And if you have any questions, as we pretty much done with the time at 4 o'clock, I'd like to end the session here. Mohini? Mohini, are you there? Okay, thanks guys for attending this session, and it was the questions were good, and if you do have any questions, again I repeat it, you could email me mallari.kulkarni, mallari.kulkarni@emc.com. I'll be happy to give my knowledge, share my knowledge.
Well, thank you so much for the insightful presentation, Mr. Mallari. I'm really thankful to you for conducting this webinar. It was a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the session would be available on techgig.com by tomorrow. Thank you all. Have a great evening.